All right, here we go with the 3-1E notes. Now, one thing I want to point out to you is that the process that we're doing here in these problems for today are no different than the process that we've done in previous notes. The only difference here is our solutions. So we're going to get these different kind of problems that have IMS or no solution as the answer, and I'll talk about that here in the next slide or two. So let's first of all go over this solving equation stuff that we've already done. So first up, again, we want to look for any parentheses. That tells us that we have to use distributive property. This is like a -1. So when we multiply this through, that'll be a -3x and a +5. So first step, bring down the 4x. -1 times 3x is a -3x. And -1 times -5 is a +5. Bring down the 2x plus 11. Next, combine your like terms. So when I look at this here, I say, all right, well, I got a 4x and a -3x. 4 minus 3 is 1. So I have 1x plus 5, or just x plus 5. And the right-hand side, 2x plus 11. Then I will move the 2x over to the other side. This is a positive 2x, so I would do the opposite and subtract 2x. 2x minus 2x is 0, so those are gone. And the left-hand side, x minus 2x is -x. Bring down the +5 equals, bring down my 11. Now I need to move the 5 over. This is a positive 5, so I want it to be a 0, so I will subtract 5. 5 minus 5 is 0. Right-hand side, 11 minus 5 is 6. Let me go ahead and get rid of this and talk about the last step. This is like a -1. It's being multiplied, so we do the opposite and we divide both sides by -1. -1 divided by -1 is 1x, and 6 divided by -1 is -6. There's your final answer for the bell ringer. All right, so let me talk about these two types of solutions that you can expect to see now. You haven't seen any of these as your answers. We've always had numbers. X equals a number, R equals a number, Y equals a number, something like that. Some variable equals a number. Even X equals 0. Okay, but now we're going to end up with these other type of solutions. So you can see the problem here. 2 times 3x is 6x. 2 times 4 is 8. Nothing new in this problem here. Combine like terms, 5x plus x is 6x. But now what happens, right here, I would subtract 6 from both sides, right? Minus 6x minus 6x. And they would cancel out on both sides, 6x minus 6x. So you will see these IMS, infinitely many solutions, or no solution problems when your variable cancels. So that's what we want to look for, a variable canceling. When you have a variable cancel on both sides, okay, both sides, that's important. It'll always cancel on one side, but if it cancels on both sides, this is when we have the possibility of IMS or no solution. Now, the way we know if it's IMS is if we get down here and we have a statement like this that is true. If we have a true statement, like 8 equals 8, or -2 equals -2, or 0 equals 0, anything like that, if it's a true statement here, then your answer is IMS. So, just the opposite then, if you go through a problem, you do all your steps, blah, 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 you get down here, and you get a false statement. So you'll see, what you'll see here is, like after these 12s canceled out, you'd end up with 15 equals 3, which is not true. That's why we put this slash here. It means it's not equal to. So if you get a false statement, false, then the answer is no solution. Okay, so again, that's what we're looking for, is the variable to cancel. If the variables cancel on both sides, key point there, both sides, then we look for, is it true, IMS, is it false, no solution. All right, so let's go through a couple of examples here and I will show you what I mean. So you're going to treat every problem the same way. We're not going to say, okay, is this, and now most of the ones you'll see now are IMS or no solution because we just did them. But when you see your, the next quiz or test, they're going to be mixed together. So you're going to treat every problem as if it's no different, and then you're going to wait and see what happens for your final answer. Over here, I need to do my distributive property. 2 times 5 is 10. 2 times negative 4x is negative 8x. Now I need to move my variable over. It doesn't matter which one we move. I'm adding 8x to both sides. And we can see here that the variable cancels on both sides. So then what I want to do is I want to ask myself, is this a true statement or a false statement? Well, 10 is equal to 10, so I know this is true, right? And if it's true, that means my answer is not true. My answer is IMS, infinitely many solutions. Now, let me just take a second to explain what that actually means. Infinitely many solutions means that no matter what number I plug in here for x, it will always be true. You can plug in 0, you can plug in 20, you can plug in negative 1/2, you can plug in pi, you can plug any number that you could possibly think of. Positive, negative, decimal, fraction, square root, any number you possibly can think of, and this will always be equal. Okay, that's what IMS means. It means there are infinitely many solutions to that problem. There are infinitely many numbers that I can plug in there and it will be true. Okay, so anyway, I just wanted to explain what that actually means. Over here, first of all, we're going to start with our distributive property. This is like a 1, so let's distribute negative 1 through. Negative 1 times 2x is negative 2x. Negative 1 times 5 is negative 5. Equals negative 2x plus 9. Next up, before we move anything, we want to combine our like terms. 14 minus 5. Okay, 14 minus 5 gives me, 9. Bring down the minus 2x. Right-hand side, negative 2x plus 9. So maybe some of you can look at that and say, all right, I know this is an IMS. We're going to finish it out just so we can show all of our work. Again, we always want to make sure we show all of our work. So add your 2x over. This is a negative 2x, so I will add it over to the left. Negative 2x plus 2x is 0. They cancel. Negative 2x plus 2x, again, they cancel, so that's 0. 9 equals 9. True or false? 9 equals 9. True. I don't know what that is. I was finishing out IMS, I guess. True. Let's try that again. True. There we go. This is a true statement. That means my answer is IMS. Infinitely many solutions means no matter what number I plug in for x, it will always be true. Next, I did one for you here. So again, my first step here would be to combine my like terms. 7x minus x is 6x. So recopy the left-hand side, 6x minus 5. Right-hand side, 7x minus x is 6x, but then bring down the plus 7. Move 6x to the other side. So this is a positive 6x, so I would do the opposite and subtract 6x. 6x minus 6x is 0. 6x minus 6x, again, is 0. So I am now left with a statement that says negative 5 is equal to 7. Is that true or false? That is false. If it's false, your answer is no solution. Okay, the answer is not false. We're just stating that this is a false equation. It's a false setup here. Negative 5 is not equal to 7. My answer is no solution. Next, let's do this one together here. Add my like terms over here. 9x plus 3x gives me 12x. Minus 10. Over here, I'm going to add my like terms. 3x plus x. So I'm going to put that in parentheses. 3x plus x is 4x. Now I'm going to distribute. 3 times 4x is 12x. All right, now let's move my variable over. Minus 12x from both sides. Okay, 12x minus 12x is 0. So my left-hand side is negative 10. Right-hand side, 12x minus 12x is 0. And since there's nothing else over here, we can't just leave it blank. We need a number to fill in there, so let's plug in a 0. Is negative 10 equal to 0? No, that is false. Okay, that is false. So that means my answer here is no solution. Let's just abbreviate that. NS, no solution. E. I have E done for you here. Again, I have it already displayed, so I'll just talk you through it. Bring down the x minus 5. Right-hand side, negative 1. This is like a negative 1. Times 5 is negative 5. Negative 1 times negative x changes to a positive x. Move the x over, so I subtract x from both sides. That cancels. X minus x is 0. So I'm left with negative 5 equals negative 5, which is true, which means IMS, infinitely many solutions. Last one, I'll do this one with you here. So first up, I have distributive property. I'm going to multiply that through, but let me first bring down my 5x. Negative 2 times x is negative 2x. Negative 2 times 2 is a negative 4. Over here, again, a negative 1. Let's multiply that through. Negative 1 times 2x is negative 2x. And negative 1 times 15 is negative 15. Now let's combine our like terms. Over here, 5x minus 2x. 5x minus 2x is 3x. Let's bring down the minus 4. Equals negative 2x minus 15. I have no like terms to combine on the right-hand side. Now let's move the x over. So this is a negative 2x. I will do the opposite and add 2x to both sides. Add 2x to both sides. Negative 2 plus 2 is 0. They cancel, but look at this. 3x plus 2x. What is that? 5x. So my variables did not cancel out here. And I don't want you to think, well, we probably did something wrong because I didn't get an IMS or a no solution. No, that's not the case. I just wanted to throw a problem in like this to show you that that's not always going to be the answer. We still have to keep an eye out for those other type of problems. And even better yet, this answer ends up being a decimal. So another reason why I wanted to throw a different type of problem at you here. So negative 4 plus 4, I'm going to add 4. This is a minus 4. So I'm going to do the opposite and add 4 to both sides. Negative 4 plus 4 is 0, so those are gone. Left-hand side is 5x equals negative 15 plus 4 is negative 11. Last step, divide by 5. On both sides, divide by 5. Final answer, 5 divided by 5 is 1, so I have 1x equals negative 11 divided by 5. You could really leave that as negative 11 over 5. You could write it as negative 2 1/5. It doesn't really matter. There's a bunch of different ways you can write this. I will write all of them for you here so you can see. Negative 11 over 5. Same thing as negative 2 1/5. Probably the most common answer I think you would have, because you're probably going to use your calculator, and your calculator will say negative 2.2. Okay, and that is perfectly fine as well. So that is your final answer, negative 2.2. All right, so again, I wanted to throw a little different one in there for the end. But remember, if the statement is true, it's IMS, infinitely many solutions. If your statement is false, it's no solution, which you can abbreviate NS if you want to. Okay? So again, like always, if you have any questions, just let me know. But otherwise, feel free to pause the video, rewind the video, look through any of these multiple times to understand what's happening here. But if you still can't figure it out, let me know. Send me an email, private comment, and I will get back to you.